I hope you've been doing well. I'm your favorite ball with a sheet on it, ghost-like. In this video we'll do some integration work for the Monte Carlo CFR algorithm that we implemented in the previous one. It won't be like the video 2 places back on the playlist where the finished work was merely showcased. In this one I'll show you how the system we have created can be extended directly with the new algorithm. It will just be some UI work and then some backend work after that. Let's get started. First, we'll extend the list of available players. Previously, we had only the enumerative CFR agent, so this was fine. But now we also have the Monte Carlo version, so we'll add it in. There are a few ways we can go about this, but once we realize that we don't want to be sending messages to train the human or the random player to the server, the correct way to do this becomes clear. No, this kind of description is too large. You can see it taking up unnecessary space in the UI. Let us pare it down a bit. And if we go back, we should see the UI shrink. Perfect. Now that we have done this, we need to go to the codebase, making sure the message reaches its target. We'll fix this type error first. We'll make the Monte Carlo player the default on the opposing side. We might as well extend the types of the messages being sent to the server, so the agent type is being sent as well. Now, if we go back to the index.fs file, you can see that the message is now expecting a player type to be passed in as well. We'll extend the model then. We'll make a design decision here. We won't require the selected player type in the UI to be different between the training and the test tab. Usually the one you select in one tab is the one you'd want to use in the other, so we won't give testing a separate field. After that, we just pass the player type from the view model into the message. We pass in the same player type for both the training and the test message. Now after this change, the server will be wrecked, so we have to go there and modify it as well so it accepts the player type. We've fixed this, so let us check the terminal to see if it compiles correctly. And it seems like it doesn't. There is a type error somewhere. It's in the play module. For some reason the writer ID is not showing solution-wide errors, so I'm relying on the terminal to tell me about those. We'll fix this one right away. Right now our focus is to just get the server working again so we can get back to work on the UI. We'll leave implementing the server-side functionality after we are done with the front end. We'll leave a few to-dos in places, so we know where we need to look after we get back to this. Let's go back to the UI file. Rider will keep a note of those to-dos, so we can easily find them again. Anyway, I've been scrolling through the UI for a third of a minute trying to find the menu, when I realized that I should just go to the start and jump into the definitions instead. I then ninja into the menu after that. Here is the training UI. We have factored its menu functionality into a single function, which makes extending both the train and the test tabs at the same time a lot easier. Over here, I know we need to use the select HTML element, but I forgot what should go inside it. Since we've used it elsewhere in the project, I'll use that as a reference for what needs to be done here. I'll make up some new CSS class for this new element that will be filled in later, and put some stamp elements. We do not want to make moves that are too big at this stage. We'll make little steps and check the UI every step of the way to make sure that our extensions are in fact doing what we think they should be doing. And it seems they are. Great. Next, what we'll do is replace those stamps with the actual CFR player types. For that sake, we'll go into the redact types and do some refactoring. First, we'll lift this array onto the top level. After that, we'll make a similar array just for the CFR player types. There are only 2 of them, no prob. Now that we've done this, we see some duplication going on in the main player types array. Let's factor that out. Right here, I admit I do not understand why the implicit yield is not working, but we'll just make it explicit. Now what we want to do is create a map of the CFR player types, string names to their actual types. A good programming practice that I am doing here is putting the things that are thematically very similar next to each other. Instead of factoring, I think that in this situation copy-pasting would also be good. I might be going a bit overboard here. We do not want a function with a single letter like F on the top level. In fact, we should have made it private. But it is good to use a single letter while you are writing it for the first time, and then rename it to something more informative later. We'll comment out the stumps as we don't need them, and then we have a choice. Do we want to pick that array of CFR player types and map it to their string names, or do we want to take the map and take its keys? This time I opted to just go for the latter, as a string creation would be more expensive than the former choice. That having said, the performance of the UI is not a factor we should be particularly concerned about. This type error is happening because we are not mapping it to the HTML option elements. Now we've done it, and it is just a matter of cleaning it up a bit here. We'll wrap it up into a single expression, no need to concatenate lists using that yield keyword. Let's check it out. Does it work? It seems like it does. The next step would be to link the select elements value property to the model. If you look, you'll see that we don't have the model in scope. Instead, we'll have to pass it in as an argument. Let's give it a try. Something like this. No, I got the name wrong. The name must not shadow the global variable. Something like this. Then we need to plug it in. We need to plug it into both the test and the train UI functions. With that done, let's take a look at how it works in the UI. As you can see, I'm trying to select enum, but nothing is changing. Why is that happening? The reason for that is because we haven't put anything to update the UI model after the user selects an item from the list. We need to set the event handler for it. If you look at the docs, you'll see that the React elements have dozens of events that take in handlers, but the only ones of real importance are onChange for input elements and onClick for buttons and the like. So we'll just pass one in as an argument. Now what we need is to send a message to the update function. Since we don't have one, we need to make one. Let's do that now. I'll just right click on the other message to get the union type definition, since it is more convenient this way. Then we'll put something in here. After that, we'll drag the scroll bar to where the errors are. Then we'll plug the message in and compose it with the dispatch function. We'll do the same for the test UI function as well. Then we'll drag the scroll bar to where that yellow bar is and implement the missing pattern matching case. After we've filled this in, we'll give the UI a try. If we try changing the selected item now, we'll see that it works. We've come quite a bit since we started. In fact, with this we are done with the UI as far as this video is concerned. The thing that really matters is dealing with the server side next. Once we do that, we'll be able to actually train the agent and play against it. Let's take a look at those to-dos. For the first to-do, I had to pause and think about it for a bit, but we don't actually need to do anything here. The class we are passing the dictionary into doesn't depend on the details of the agent at all, and just samples its average policy. So we can leave this as it is. In order to be able to run the Monte Carlo CFR training, we'll need to maintain its dictionaries in the server model. So let's add them right now. We'll also need to get the type of the value dictionary from somewhere. We'll go through this quickly. Here we are just defining the type of the dictionary that the MC CFR agent is using, so we can import it in the server model. And now that we have that, we need to put the new agent to work. We'll have to pattern match on the player type. In the train case, what we need to do is start factoring in order to put in the requisite functionality. When doing this kind of programming, it is pretty difficult to think through things all the way ahead of time. I basically have a goal here, which is to implement the training for the two different player types. And what you see on the screen is just me moving pieces around in order to figure out what fits better. I wasn't really sure what to do at first, but then I decided to just factor the loop here into their own functions. As the final part following the loop that converts the dictionary into a map is independent, it can be left alone. It just needs the dictionary to be passed to it. What we'll do here is duplicate the train function and modify them so the right classes are being passed into it. Later, we'll go back and factor out the init variables and delete them so they are on the top level. What we need to do here is change all those enums to samples, and then I implemented this yesterday and forgot that they weren't MC but sample, so following the link here jogged my memory a bit. In the passive sample, we need to modify it so it takes in a boolean which acts as a switch on which policy to use, either the current or the average one. We just need to move things around a bit and it will be plugged in. We already did something similar to this for the passive enum. We get the policy arrays, branch on it and then normalize it. Back in the train MC function, we don't have the type errors for this anymore. And after we've changed the other MC for sample and plugged the value estimate dictionary into it, we won't have a type error for it either. In this part, I get a bit confused as to where the chance sample class is, and start wondering whether I even implemented it. I think I haven't, and in that case we can just make one using the enum1 as a template. Let's give that a try. We'll go for a straightforward approach here. Since we just need to pass in the card and the mask into the continuation, we have just a function for that, namely sample card. We'll copy the start of reduct chance enumerate, change its postfix to sample and then plug the sample card into it. We'll do this, and then go back to see if there are any errors. I'll have to ask around why Rider is not showing solution-wide errors later, but for now, I think I saw an error in one of those files earlier. Here it is. We added that boolean switch argument on whether to use the current or the average policy. Since this is the play module, we want to use the average policy. So let's put in false as the second argument. And then we can go back to the server and finally finish the train case. No type errors here. Wonderful. Next, we'll uncomment one of these and then finish the train MC function. All the arguments are in place and there are no type errors in the train case anymore. Effectively we are done, but before we move on, let's factor out the loop. In situations like these, my own practice is to create a template function out of it, something like so. This might seem as just a matter of aesthetics, but there is a thin line between useful code and clean one. If you think about it in depth, there is no difference between all those interfaces we have made for the reduct game itself and the factoring we are doing here, apart from scale. Is this good enough? No, let's factor that D as well. Now it's good. We can get rid of that to-do, and what we have left is the test case. The test case is easier because testing is here for reliability. We don't need to use the Monte Carlo algorithm, in fact we shouldn't. Instead, since the algorithms are very similar, we'll pass the dictionary for whatever agent we are testing into the enumerative test. This way, if there are any bugs in the Monte Carlo code, it should manifest during the test. And I see we have one more error left in the start game case. The reason this is here because it was designed with only a single trained agent in mind. I haven't demonstrated it yet, but if you go to the UI, you can have the CFR agent play against itself. But now we have two, so what should we do? Fear not. We'll just go into it and pull out some of the functionality from the play game function into the start game case. Do some redesigning and then it should be on solid ground once more. The design of the play game function was right with respect to the context it was originally created in, but then the context changed and now it isn't. After we fix this, we'll be able to train and test the Monte Carlo player for the first time. Over here we'll pare down the game function drastically. We'll get rid of those Fs and then massage the server until everything makes sense. Depending on where you put it, implementing the same piece of functionality can either be very hard or easy, and here it is easy. So we'll write all that we need here. In fact, we could have factored the game function even further, but my sense is that we are perfect now. I really want to highlight how easy changing the existing codebase is in F#. What we are doing here would be a lot harder in a dynamic language, as we'd have no idea when changing something would break anything else. Extending existing functionality and refactoring is a breeze in F#, and unlike in C#, the types aren't getting in your way. I've gone and started the program in the background, and now we can give it a try for the first time. Everything should be fine. And now we see our first problem. I've forgotten that there is a huge difference between a single Monte Carlo iteration and a single enumerative iteration. And if we go into the test tab and give it a try there, it doesn't seem like the agent is training. Given how far the enumerative agent can drive its win rate against the Monte Carlo one, it is fair to say that it is most likely no better than a random right now. That can be for all kinds of reasons. The most likely one is that there are not enough iterations. But even so, at 2K, my hunch is that it should be doing better than this. Another reason might be that the algorithm is getting stuck in a local minima due to the lack of an explorative policy, and I really shouldn't have left the important sampling part for later. Lastly, there might be a vanilla kind of bug where I am simply passing the wrong thing into something. We'll go over it all in turn. Just out of curiosity, I tried training the enumerative agent for a bit, and when I go back to the test tab, all hell breaks loose. We'll start by dealing with that error first. Which variable is being undefined? As it turns out, this error didn't have anything to do with the introduction of the Monte Carlo agent, but with the refactoring we did 2 videos ago. If you recall, we had 2 React char components, and we factored them out into a template that abstracts the common functionality. If you look at the x-axis data key property, you'll see an error my hasty refactoring has introduced. This data key is only needed for the training chart, but it would also act upon the test chart. We can comment this out, and if we went back to the UI and tried it out, absolutely nothing would have changed. The actual error is a lot weirder than that, and the way to fix it is to get rid of the partial application on the top level let statements, as well as give them the React component annotations. That should fix the problem. I don't understand why the chart component is behaving like this, but this episode has taught me that I should really go through the docs in order to figure out how React actually works. But this issue is really a bug in the chart component itself. I found the chart component to be somewhat buggy in general. For example, if you have a chart component on the page and you try zooming in and out, it will wreck the UI. So I do not like the rechart components due to that, but they are useful for keeping track of training, so we'll have to bear with them. Another thing this episode has taught me is that even though refactoring out duplicate functionality is a good thing, I really need to be wary of that when the types are loose like in the current situation. Because the chart component doesn't have the element type as a part of its definition, it allows the x-axis to take in a data key that doesn't match the type of the data. Since I found one error, I'm going to take the chance to refactor it a bit better. I'll make use of the modules and put these functions inside them, and do some renaming so that what should be the chart arguments don't necessarily linger on the top level. In case you are wondering, the way I figured out this bug is that I realized that switching tabs crashes the UI even without switching the Monte Carlo item to enum. After that I went back through the old branches until I found a version that worked, which was in tutorial 5. After that I fiddled around for a bit and figured it out. It was a pretty weird bug because to my mind the 2 code fragments should have been equivalent. But it turns out they weren't. You really do need to be suspicious of your basic assumptions when debugging, above all. We'll plug in the views here. After we are done with this, we'll go back to seeing if we can get the Monte Carlo agent to train successfully. Instead of assuming that we have everything right, we'll do a little test to make sure that the UI still works. And it does. And actually, before we move on, let's just put the type annotations on the 2 views so they cannot take literally any kind of generic list argument. Right now they take in generic lists, and as an aside, back when I did the refactoring, one of the mistakes I made is having the template take in object lists instead of generic ones. Haste makes waste. Now let's try ramping up the iteration count for the Monte Carlo version of the algorithm. I said that the game has 500 public states, so in order for it to match the enumerative version, we'll have each iteration do that many sub-iterations. Having too many values being sent to the client will hammer it, so it would be better if we did a bunch of sub-iterations and then averaged out those values before sending them. I think that the enumerative version has to go through almost 2k nodes on each iteration. I haven't timed it, but I guess it does a few dozen iterations per second, which might seem slow. But if it was done in Python, it would take over a minute to do 100 iterations. Maybe even a few minutes. But that doesn't mean the version we have is fast. The kind of code we've been writing here is clean, But due to all those interfaces we've been using, it isn't performant. That doesn't actually mean that using interfaces is wrong, it is just that F# and the .NET JIT don't have the capability to inline them properly. In future videos I'll cover a language called Spiral that has extraordinary inlining capabilities, which would allow highly abstract code like that for the CPS LDAC game to be compiled very efficiently. Besides performance on the CPU, that kind of efficiency would make it suitable for compilation on the GPU and restricted AI hardware like we'll have in the future. But that's for another video. Right now let us finish making this nested loop and then we'll try training it in the UI again. If it doesn't work, we'll segue into important sampling and explorative policies next. Let's give training it a try. We'll start off by trying out a small number of iterations and then ramp them up as we go along. Our programming undertakings won't always end in success, at least not right away. We've checked out the action probabilities for various sequences, and many of them were uniform, which tells us that the algorithm is not exploring properly. It is getting stuck in local minima instead. In the next video, we'll extend what we have done so far and have the agent explore properly. Once we do that, the performance will improve. Look forward to seeing how important sampling is done in the next video. If you found what I've been doing so far to be of interest, please like and subscribe. It tells the YouTube algorithms that these videos are worth showing to other people. And the more viewers I get today, the lower my chances of ending up on the streets a few years down the road. This has been Ghost-like, and I'll see you in the next video. Stay safe.